Here we simplify complex fractions. We're going to do this in two different ways. We'll do this by example. Consider the first fraction, that's 3z over 2xy divided by 3x over 10yz. This is a complex fraction because the fraction has a numerator and denominator which themselves are fractions. So the first method is to go ahead and do the fraction division. So to do that, we take the numerator and multiply by the reciprocal of the denominator. That's how you divide fractions. Then we recognize the common factors, in this case 3 and y. We reduce the fraction, and we'll see that 10 is 5 times 2, so we see an additional factor of 2 in common. When we reduce that, we get 5z squared over x squared. This is okay as long as y is not 0. In the second method, we find the least common multiple of 2yx and 10yz, which are the denominators within the numerator and denominator. The least common multiple is 10xyz, so we'll multiply the numerator and denominator by that least common multiple. Then we go ahead and do the multiplication and note the common factors within the numerator and the denominator. We reduce the fraction. And we note an additional factor 3 in common once we have eliminated the denominators in the numerator and denominator. And we get the same answer that we got before. In this next example, we have a sum or a difference in the numerator and denominator. So in the first method, we're going to divide the fractions, but to do that we need a single fraction in the numerator and denominator, so we'll go ahead and perform the indicated operation. In the numerator, we add, we get a common denominator, z squared. We get this. In the denominator, there's a common denominator of z cubed, so we have to multiply that term by z squared over z squared. So we get this. Now we go ahead and divide those fractions by multiplying by the denominator's reciprocal. We do that multiplication. That's this, and recognize common factor of z squared actually. When we reduce it, we get this expression here, and this is okay provided z is not 0. In the second method, we're going to note the least common multiple of z squared z cubed. We get that to be z cubed, so we multiply numerator and denominator by z cubed. When we do that multiplication, we need to distribute, so the z cubed appears in these 4 places. Then we do the cancellations, and this term on the upper left, the z squared cancels, leaving us with z. In this term, the z cancels, leaving us with 3z squared. Here, the z cancels, leaving us with 2z squared. And here, the z cubed cancels, leaving us with a 5. So we get this. This is a perfectly fine reduction or simplification, but if we want to see that it's equal to the left-hand side, we should factor out a z from the numerator, but nothing further cancels.